Well, thanks for allowing me to be a part of this event this morning. We're going to talk a little bit about combined heat and power. Again, as Bill said, I work for Hall Associates right down on the Emerald Parkway. And I like to refer Emerald Parkway as actually Energy Row. A lot of people don't realize it, but right here in Dublin we've got Delta Energy, we've got IGS Energy in our company, and we're probably the least known in the energy business, but we do a lot. And I'm going to do that theme as I go through here, our role in the energy market. We focus in 5 predominant areas. I'm not going to go into all those in detail, but waste management, obviously there's waste energy. When we do waste energy projects, we have a landfill gas energy project in Akron, Ohio, but we also do traditional waste services. Shale oil and gas, we do a lot with the oil and gas industry, a lot of our ecological work with them, looking at pipeline routing, things like that Bill's group is heavily involved in. Brownfields, old redevelopment projects, a lot of old dirty industrial sites. We go in, we clean up, we get ready for redevelopment. The most notable site right here in Columbus, Ohio is the casino site. The old auto plant that had been closed, we went in, demoed it, cleaned it up, and then it was sold to Penn Gaming, and that's where the Hollywood Casino is. One of the things that on brownfields that we often find is that there's land that can't be utilized. It's contaminated for one reason or other, it's too expensive to clean up. At times we've actually built solar projects on those brownfields. Environmental group, wide range of services. Again, a lot of those touch the industry. In the wind industry, we've done a lot of environmental work, supporting some of the large wind development in Ohio. And then alternative energy, which I head up, we'll talk about today. As I was going through, we are a very diversified, and that makes us unique in this market, is that we aren't just focused on one area. When we talk about alternative energy, we're involved in solar, wind, biogas, combined heat and power, and waste heat recovery. Not only do we invest and develop these projects, but we also provide consulting service. I'm actually consulting on a very large project on a closed landfill in Brattleboro, Vermont right now. Should get off and going this year. And so today we're going to focus on one aspect of alternative energy, combined heat and power. How many people really know what combined heat and power is? Sue, you better raise your hand. You've seen this before. You're getting the quiz. So combined heat and power is basically making both electricity and thermal energy or heat from the same fuel source. That fuel source is traditionally natural gas, but it could be biogas or wood chips or other types of fuels. And so that's what the focus is. You'll hear combined heat and power, CHP, cogeneration. Those all mean the same thing. One of the other terms that you'll hear, and we'll talk a little bit about that today as we get into the details of the city of Dublin, it's called island mode. One of the unique things about these combined heat and power projects, the type that we focus on, are behind the meter. We develop them for a specific customer, a distributed generation resource. And the focus is giving customers an option for supplying their own energy. Obviously you can buy it from American Electric Power. You're always going to be connected to that grid, but now you can take some control over your energy by implementing some of your own generation. It could be solar, it could be wind, or it could be combined heat and power. The businesses that are interested in this type of technology are businesses that also have thermal energy loads. They have boiler systems running 24/7. Think of the Dublin Rec Center. They got 2 swimming pools in there. They got to keep those pools at temperature year-round, 24/7. That's a lot of heat to generate. And so what island mode does is that in the event there's a grid outage, how many people remember, what was it, about 5 or 6 years ago, we had that big storm come through? I know my house was out for about 5 days. Well, during those times, our system can disconnect from the grid. You have to be able to disconnect for security purposes. You don't want, or safety purposes, you do not want power going back on the grid when guys are out working on it. So we automatically disconnect, and then we restart the engine, and then we can provide power to that island. That customer becomes an island in a disconnected grid or a grid that's down. This is maybe a little complicated, but a lot of times you hear about waste heat recovery. In Ohio, there's combined heat power and waste heat recovery. they're two totally different types of energy generation. Waste heat recovery is where you're actually utilizing the heat as your fuel source. There are particular types of engines called organic Rankine cycle engines that utilize heat, and they can actually convert that heat directly into electricity. We're not going to focus on that today. In Ohio, waste heat recovery is considered renewable energy. Combined heat power is not. Combined heat power is considered energy efficiency, and that's why here in Dublin, it's greener in Dublin through energy efficiency. And we'll talk about what that really means as we go through this. When you look at, this is the basic premise, so you focus on this one slide. Today, generally businesses that have both sources, like the City of Dublin Rec Center, they're buying their electricity from a power plant, and they have a boiler system that produces all the hot water for their showers and for their swimming pool. And typical energy power plants, like AEP's coal-fired power plants, they're 35% efficient. What that efficiency means is how efficiently are you converting the energy into fuel to electricity. And so when you look at this, you put 91 units of fuel into that power plant, you only get 30 units of electricity out. What happens to the other 60? Well, it's either line losses or most of it is dissipated in heat. When you think of a light bulb uses energy to convert light. What is the natural byproduct of a light bulb? You ever grab one after it's been on a few seconds? Heat. And so generally, all that energy is just wasted. When you look at a boiler, now boilers are more efficient. They're about nowadays 85% efficient. So you put 56 units of fuel into a boiler and you get 45 units of heat or steam out. And so there's your 75 units of energy being created from those two. It takes 147 units of fuel to create 75 units of energy. But if you look at a combined heat and power unit, we put 100 units of fuel into that device. It's an engine. And when that engine is running, what's it give off? Heat. Typically that heat just goes up through a stack. Well, rather than just allowing that to exhaust through the stack, we utilize a series of heat exchangers to capture that heat. All that heat is transferred and creates hot water. That hot water then is transferred through another set of heat exchangers to the building swimming pool loop. So when that water comes back after it's been sitting in the pools and is running back, it starts off from the boilers typically about 184 degrees. When it's coming back at about 150 degrees. And the job of the boilers is then to heat it back up to 184, and that cycle just continues. So what we do is we intercept that water before it hits the boiler. And we utilize the heat from our engine to preheat that water. And actually, we get the water up to 184 degrees. And so now the boilers don't have to run. We've just offset that fuel source by utilizing a combined heat and power unit. And so when you look at that energy efficiency, you're going from a total of about 50% to about 75. We're actually higher, about 84% efficient at our unit because we have a higher electric generator. And so you're almost, you have a 50–60% increase in energy efficiency. Much better to use that fuel, lower emissions, better for lower greenhouse gases. So the Dublin CHP overview. Our role in this is we manage the development, design, construction of the project. We partnered with IGS Generation. This is the generation subsidiary of IGS Energy. They finance the project. The system is 248 kilowatts, produces about 2 million kilowatt hours a year. To put that in perspective, average homes use 10 to 12,000 kilowatt hours a year. So it's enough energy to provide the annual consumption for about 200 homes. Then we produce about 1.5 million BTUs of thermal energy, which is really the heat source. This system utilizes natural gas, which they buy from IGS Energy. So it really works very well. Our system is nearly 90% efficient because if you look at that generator on that one chart I showed you was 30%. We bought a high efficiency engine that runs at about 42% efficiency on its own. This is, you all know the rec center, and this is the main entrance coming in. Back there is where they have the dumpsters and some chillers, so we were able to place that unit right back there. You won't even see it. You hardly even hear it, and it'll be running 24/7. So every time you walk in that main entrance into the rec center, the CHP unit will be running. This is actually what the engine looks like. This is it's an MTU engine imported from Germany, This concept of combined heat and power is far more prevalent in Europe than it is in the United States. And we're seeing it become a more common application in the United States, especially on the East Coast. Energy rates are higher. And actually on the East Coast now, they require every CHP unit that is installed to be designed to be able to operate in island mode. Because when Hurricane Sandy hit, all that grid went down. One of the companies we work with out there, Capstone, every single one of their units was able to fire back up and provide emergency shelters for facilities. So, creating value for Dublin. I mean, the challenge of these types of projects is, one, they're complicated. Two, they cost money. And, energy, having grown up in the energy industry, these are not, quick flips. You don't get a 1-year payback, a 2-year payback on most energy projects. This engine should run 20 years, properly maintained. These are long-term assets, and so you've got to be able to amortize your investment over a long period of time, which again, a lot of businesses that we deal with say, if you can't give me a 2-year payback, I'm not interested. And so that's why we work with companies or finance them ourselves to find financing alternatives to create value. And that's what we've done here. One of the things that we were able to do when we talked to the City of Dublin, right now they have 2 boilers and a 3rd backup boiler. They were going to replace that backup boiler because it was a 1970s vintage. Well, and that was going to cost them at least $50,000 to $70,000 to do that. And we said, well, if you put a CHP unit in, you've got a 3rd boiler. You no longer need to do that. So they had immediate savings right there. The way that we structured the contract is through a long-term energy supply arrangement. And so they didn't put any money out of their own pockets to put this unit in at the rec center. IGS, well, we funded the development, IGS funded the installation, and all that money is being recouped over a 15-year contract. One of the things that it does is we fix those rates so that, energy rates are going up, and they're going to continue to rise, especially the electric, with the closure of plants, with the environmental, applications that they have to invest in. So electric rates are going to continue to go up. But we fixed the City of Dublin's rates for this period of time, and so as rates go up, their savings grow. They should save easily $200,000 over the life of that contract. Again, it provides emergency power. We designed this system to be able to operate in island mode. And so in the event that we have an outage, there will be light, heat, hot water at the rec center. They can now utilize that as an emergency shelter. If they were to go out and just buy a backup unit to try to do what we do, they would have to spend $150,000 on that. So they've saved money there. And then again, because it does fit very well with its greener in Dublin. It does reduce greenhouse gases. It's equivalent to taking 187 cars off the streets and 900 tons of carbon dioxide saved. This just talks a little bit about the island mode. So really what it is, it's just designed so that when the electric grid goes down, the unit senses a loss of power. It shuts down and then physically disconnects from the grid. So if AEP's out working on the lines outside, there won't be any power that goes back out onto the grid. It physically disconnects. Right now we're going to manually restart it, but we can set up to automatically restart, and it will restart and it will provide the whole base load for the Dublin Rec Center. So if it comes down to it, when you look at these projects, it comes down to money. And that's the challenge. This was, in excess of a $500,000 project. And again, we worked with Dublin Rec Center and the City of Dublin administration and IGS to structure a contract over a 15-year period. Again, provide them long-term savings, enables the investor then to recoup their investment. They get a monthly bill from the CHP system, just like they do from their other utility investments. So now they just have one more energy source and a lot more security. So with that, I will open it up to questions.